Our next speaker comes from Chevron Corporation. Please allow me to introduce Craig Evans. So I invite Craig to, there you go, Craig. We can see you. Can we hear you?
Hello, everyone.
There we go. Thank you. So and one thing that is important to highlight is Chevron has been actively participating in previous PPI symposiums and events in general. Today, Craig will share with us new stories, how they have continued applying PPM in construction, obviously, because this session is about construction. However, he also brings a very short story about something that they have done in engineering, which he will take us through. A bit more about Craig Evans. He is currently a senior advisor of operations science at Chevron's capital project function. Craig has spent about 28 years in Chevron's capital projects organization and has held a variety of roles, key roles, including being responsible for the deployment of the Chevron's project management system across the portfolio of major capital projects in Europe, Eurasia, and Middle East. Craig has been directly involved in Chevron's implementation of project production management on the Future Growth project, as well as other ones, especially in his new role as the Senior Advisor of Operations Science. Finally, Craig holds a Master of Business Administration from Deakin University in Australia, and he's joining us from London today. So one thing that I should say first, Craig, if you don't mind, Craig is very, very passionate, extremely passionate about excellence in project delivery, right? And I think that's something that is driving his focus on looking for new ways of doing things and looking for new ways of delivering projects, especially within the Chevron Corporation. So without further ado, Craig, welcome, and please proceed to share your screen.
Thanks, Roberto. Hopefully everyone can see.
We can see your screen, so I'm going to shut down my video and it's over to you. Thanks.
Excellent. Thanks, everyone. And thanks, Roberto, for the introduction, and thanks, everyone, for joining me today. As you're aware, I've probably spoken a couple of times before at the symposium, previously mainly around EPC. Today, I'm going to take you a bit further into the journey that Chevron's going on with project production management as a whole. First of all, a little bit around why project production management, then how we're using different aspects of it on projects, and specifically I've got a case study around that, and then also some benefits and learnings, and then also I'll have a little bit of closing and I'll leave some time for questions and answers. I always like to have an opening thought on these things, and 2020 has been one of those years that we'd like to forget, and we're starting to think about restarting work and getting back to normal. People say, well, maybe if we took a different view in the future and said, hey, what can we do? How can we do this differently? Let's not do it the same again. Let's take this opportunity to change something. Never waste a good crisis, I like to say as well. So just keep that in the back of your mind as we're having discussions over today. So why is Chevron implementing project production management? Well, you heard Gary earlier today talk about how as an industry and as a company we're not meeting expectations of our shareholders and also just our general performance we put on ourselves. I would say if we could actually just meet cost and schedule, that would be an achievement in the current environment. Additionally, our competitors are not standing still. So they are becoming more competitive and more predictable. And we need to compete with other industries now for capital from shareholders as well in that space. So one other aspect of how we do projects is that we're in a resource business and we deplete reservoir fields. So we're in the business of continually doing capital projects to replenish what we produce each year. So if we don't do projects, we'll go out of business if we don't do projects well, we'll definitely go out of business as well. Chevron's definitely been on a bit of a journey. So we started applying aspects of project production management, specifically project production control, back in about 2013, 2014 in China. And then we moved on to an onshore LNG project in Australia in 2015. And once we saw the benefit of those two projects, we specifically went out and started deploying project production control on more and more projects around the place. In 2017, we started looking at our projects more as production systems and planning around that versus just going into a project once it was up and running and controlling it. Specifically, like any project, and I think sort of Jim mentioned it before, production control has sometimes been implemented when a project is in triage. We wanted to try and get to the project before that point. So what we wanted to do is, look at the project or an element of a project as a production system. What allowed us to do this is probably we had improved our fluency in operations science over the years. If we'd gone and tried to do this straight away, I think we would have had a lot of resistance and probably not really understood the results of what we were seeing as well. So an element of fluency also helped us understand this. So what does really modeling a production system, what a project production system look like? It's not a detailed schedule for sure. What you want to look at is the various steps in the work process that are going to occur in sequence. You notice I specifically left out the word time there. You don't want to add time to the production model initially. You want to map out the workflow, ensure people are in the right sequence, and then when you can start looking at how much throughput I can get through the system, then you can start adding time to a production system after that. Also, when you do a production model, you can identify a bottleneck, like you can see there in the top area in the high-level map. And you can then detail that. You can then detail that out in a lot more with the project team. It's like, okay, where are my problems in there? The other thing as well is by starting at the higher level, you can also apply production modeling, I would say, when you're looking at different alternatives, such as am I going to modularize a project, and we'll talk about modularization in my case study, or am I going to stick build it? Those elements are going to have a significant impact to the overall production system of a project. When do I need my engineering deliverables? What is my sequence of construction as well? Additionally, when you look at procurement, where am I going to buy things from, and where am I going to transport those things around the world? And then we're able to identify, capacity issues, bottlenecks, and elements like that throughout the production model. So specifically, what did we really go and look at? So we'd learned from a previous project, and I mentioned the onshore LNG project, that logistics is a critical element of a project and a project success. So what we wanted to look at here was, do our logistics systems have the required capacity? So we had a process, and I'll go through it in a bit of detail, but it had ocean-going logistics, inland logistics, offloading and storage, and then stacking and final installation of a module. Now, our modules were large in scale, a couple thousand metric tons each, and I'll go into a little bit more detail in those in a moment. And the other part of this is, how do we actually eventually integrate our model with production control? So here is our overall logistics production system model. So what we did here, we sat down with both the logistics team, the team we had at the port for offloading and storage, and then also the stacking team. So our modules came in either 2 pieces or 3 pieces and had to be stacked on top of each other. They were fabricated in the Far East. So this is where the ocean-going logistics come in. And then you can see a whole bunch of barrels there. So that's a stock. So that's what is coming out of the fabrication yard for these modules. So then they were transported by ocean-going vessels to a transshipment port, which is where we say the inland logistics occurred. So here they were offloaded at the transshipment port. Depending on the weather window, they were loaded onto another smaller vessel, up an inland waterway system, across another sea, and then they reached an offloading port at that location. Then they were offloaded and stored and eventually transported around 40 kilometers to the stacking facility. Now, the stacking facility was a craned facility. We had 2 cranes. We had a ringer crane and a gantry crane. And what we wanted to understand was, where was the bottleneck in the system? Initially, a lot of the concern, I guess, and thought was that it was going to be in the logistics system and that, construction would get it all done. And we'll see in a moment where the issue really was. Additionally, the logistics team did have modeling going on, but they were only modeling their processes. Once it really got to the offloading point, logistics had finished their job. It then became a construction issue. So we needed to link the entire system together. So what did we find out? So really what we ended up seeing was that the logistics was not really the issue, and it was quite well balanced. So the numbers on there is the utilization rate for each system. So ocean-going logistics was utilized at a 48% level, inland at 52%, and offloading and storage was at 49%. You might think that those numbers are a little low, but it really depends on what you're trying to achieve and trying to just get a flow through the system. We may have wanted to increase that a little bit. What we could have done is actually probably reduced an ocean-going vessel and reduced some of the inland logistics storage. Utilization rate would have gone up, and we could have saved some costs in that facility, those facilities, sorry. What we did see that our stacking facility was utilized over capacity, so about 40% over what it would, over 100%, and we don't want to utilize our facilities at 100% capacity. A good example there, and you may have heard it before, is if I'm on a freeway, I'm at 100% capacity, it means I'm pretty much not moving anywhere. So what we wanted to do was, let's look at our highest capacity. Now, what ends up happening the first time here is, we'll go down to the, so what happens here typically is that we'll say, okay, let's add more capacity to that. So the question was, will we add another crane? Now, adding another crane of this significance was going to be a large dollar item. Plus, we're only 40% over the capacity of 100, and maybe want to get down to 85%. So was there a way to do that without adding additional capacity? So we really wanted to look at, could we improve the workflows or the processes in the field to improve our throughput? So what we ended up looking at was, here's a little bit more detail of the module stacking process. So you can see it arrives on site and it sits in stock. We go through a pre-stacking process of where we might take off some sea fastenings, put some internal scaffolding in there. Then it moves to a stacking facility, so either a gantry crane or a ringer crane, and it's stacked at that location. And by stacking, it's then typically bolted together or welded together. Then it moves to post-stacking, where it will have some of the scaffolding pulled removed, some other elements put into it. Then it's ready for transport, so it moves back into a stock. And then it moves from transport from the location, and then we set it on the module. So what we're looking at here is, can we actually improve this process? And what we did by applying production, so let me go back a step. The model identified that the stacking facility was the bottleneck. So then we went and used production control to improve the throughput in this. By identifying standard work processes, by controlling the work and allocating the capacity through production control, we're able to improve the throughput of the stacking facility and not require the third crane in that element. We're also able to reduce variability in the system. One of the biggest impacts in this location is wind. As soon as we hit 11 meters a second, we cannot lift anymore. What we were able to do is identify, when the wind typically got to that point, and it was later in the day. So if we had arranged lifts in the morning and some of the more other manual work in the afternoon, we're able to improve the throughput of these facilities. The standard work processes also gave us some other insights as well, that a module actually was not being worked on up to 45% of the time. So as a component was going through the system, whether it be, you know, the 2 separate pieces of a module or the 3 separate pieces of a module, some of those components were not being touched 45% of the entire duration it took to get through the system. So what we would refer to as the cycle time. So there was opportunity to reduce the overall cycle time as well as we moved various components through the system.
5 minutes, correct.
Yep, thank you, Roberto. So what do we do to control capacity, inventory, and variability? So you heard Jim speak about this a little bit in his presentation just then. So very much developing standard work processes. So even though each module was bespoke and different, the process for pre-stack, stacking, post-stack, transport and installation was similar in each case. So we would use standard processes. Then what we would do is we'd use those standard processes to rapidly develop a production schedule. So we could explode our schedule into daily tasks very quickly with the project team. Typically, you know, you'd see us have a production scheduling meeting once a week, and that may go for about somewhere between sort of, you know, 1 to 2 hours most. And that was really planning out the next 3 weeks worth of work. Then within the daily production planning meeting, we would allocate capacity. Now we were allocating capacity across various different contractors on location. So we had survey contractors, we had transportation contractors, we had the lifting contractor, we also had the mechanical integration contractor, and there was 2 of those on site. So we were actually allocating capacity across 4 or 5 different contractors on a daily basis. Additionally, once we had some analytics and we had some runtime, we were able to look at the analytics coming out of our CVX PM tool, so Chevron Production Manager tool, and we could use those analytics to help drive performance. Like I said about, you know, that we had a lot of time where components weren't being worked on. Through the standard processes, we could identify the lag time. So at the time a component, one task was completed to the time the next task started, we're able to identify those lag times. So results and learnings. So overall, we reduced the schedule duration for the stacking for a particular year by 3 months. So that was roughly a 30-month saving in duration there, which meant either those workers could go on and do other work, or we could demobilize early because we're a weather window affected stacking facility. There was no requirement for the 3rd crane. So in this environment, it was remote. A 3rd crane would have cost around $50 million around that. So we definitely did see, so that was really cost avoidance in that instance there, and also say, you know, some cost savings through the 3 months around that. Learnings. So adding capacity is not the only solution. That was one of the big elements that we were able to educate our team on here, that they could actually get better throughput the system by actually optimizing workflows and not just adding capacity. The other one I talked about, the lags. So construction, a lot of the time focuses on the capacity waiting for work. So the people waiting for the work. Equally important is the work waiting for the capacity. So when could the work move to the next station there? And then additionally, by reducing the WIP or the through in pre-stacking, we weren't getting a big bottleneck in that space. We actually ended up requiring less capacity through there. So one of the things coming out of this is really, you know, we could model with the production system optimization process. It was informing us where our bottlenecks were, and then we could control and drive the performance with production control. That was the module case study. I wanted to just spend a quick 1 minute, if I can, Roberto, on a smaller scale application, in engineering. So this is looking at piping isometric drawings, or, you know, it could be applied to any kind of drawing. So this work was going to be completed over roughly a 6-month process. So we mapped out the production system. In this instance, the capacity or the resources of people. So we had a predefined number of people that the contractor told us, this is how many designers I'm going to have, and this is how many engineers I'm going to have. Out of that, we're able to identify that the bottleneck was going to be designers, not the engineers. So you'll see that the blue line, hopefully it's showing as blue, or the top line on the chart is showing what the contractor forecast production was of isometric drawings, or let's just assume drawings. The line at the bottom, or the orange line, was what the model told us was going to occur with the allocated capacity. So they wanted to finish by the end of, I think it's October. We were predicting they would finish by the end of December, based on the capacity they'd allocated. What started happening, you can see the black line was starting to track the actual. They didn't add any capacity. They moved forward with what they had planned to use, and they were close to or tracking the model that we had. Now, here we didn't apply production control. We were just monitoring the work they were doing in this instance. And then you can see they added additional capacity, and then you can see it then kicked up and ended up finishing, pretty much between the month of October and finishing around the end of November, so 1 month later than expected. What I just want to show here is that it doesn't have to be a large piece of work to model a production system. You can look at a smaller piece of work, a sub-element of work within both engineering, you could do procurement, or construction elements, and then control it with PPC, and you'll see the results come out of that element. So with that, just closing, so I'd like to thank all of you today for listening to me again for the third year running, if you've been here the last 3 years. Our journey continues. I've only been in this new role since October, so I've got a lot going on next year in how we continue to move and integrate operations science into our capital projects organisation. So with that, Roberto, back to you.
Thank you, Craig. Really very interesting story. I think for you keep teaching us how an organization like Chevron, which is a very large organization, is approaching, management of your projects, management of your capital. And I think you mentioned the term production systems not only once, but multiple times. I think that is part of the key, and how you have looked at modeling production systems, how now you're looking at controlling production systems. The first question I see here, it's about that actually. And this person in the audience is asking us the following. Well, actually, two questions combined in one. So let me see if I can do a good job here for you. The first question is, are those processes you were showing us the schedules? That's the first element of the question. The second one is, how do you identify production systems in projects? How did you, Chevron, do that?
Okay. So the processes, as I sort of mentioned at the beginning, they're not schedules. So what you're doing is you're getting down with the people who are going to execute the work, whether it's somebody in engineering or whether it's somebody in procurement or construction, and asking them, just tell me the steps that you're going to go through to execute the work. Don't give me a time, don't give me duration, just tell me the steps, tell me the interface points you have with that process. So essentially that's where we start. Then we start looking at what's the throughput we can get through the system. So whether that's people or cranes or how much work, then that's going to define when you're going to be finished at the end of the day. So it's not a schedule where we typically look at something and we'll put a bunch of bars on there and say this is how long it's going to take us to get there. We're very much defining the duration based on the throughput of the system. One thing where Chevron is moving to, this was decided this year, is we're going to start out with developing workflows before we develop P6 schedules. So the first thing you get on a piece of paper is going to be a workflow, not the actual duration of the schedule. So that's another element there. The second one, I would almost argue that every project is a production system. You may only produce something once, you may produce something hundreds of times, but it still has an element of being a production system and will behave according to the laws of operations science. So therefore, identifying them, I guess, is not hard. Maybe the part is identifying the ones you want to go work on is probably the more important element there. You can see how I showed that we identified there was 4 mini production systems linked together to deliver a module. We focused on the one that was critical. There wasn't a lot of benefit to us to go and focus on the other 3 that were delivering what they should have done. we could have actually maybe, on those improved the utilization of them would have been the opportunity there. So cost saving, but we're already into the process and it had already been set up.
Thank you, Craig. So we do have a couple more questions. So let me take you through this, the next one. This is about current practices. It says, what current project practices have you seen that are the most difficult to overcome when adopting PPM, and why you think it is that way?
This is always an interesting one. I'm probably going to talk about this a little bit as well. I'm on a panel at the end of this project as well, at the end of this event today. Sorry. It's preconceived ideas, I think, that projects don't act as production systems. I think I made a statement last year or the year before that we have flat earthers within projects that will believe in single point load of gravity and construction, concrete and things like that, but don't believe that operations science applies to them in projects. So one of the hardest barriers has just been to get people thinking in an operations science mindset. Some of the other things is what we sometimes see as best practices aren't necessarily best practices straight away. There's potentially a lack of empirical evidence to support those. Versus when you've got something like a Little's Law, you've got science behind something as well. So I think changing the mindset in the industry that we can take what, say, manufacturing have done, or we can take operations science and apply it to our projects is one of the hardest things to overcome.
Excellent, thank you. We do have a question that I believe is related to what you just mentioned, and it's about work in process or WIP. The question says, how do you identify WIP in construction processes, and what is the impact on deadlines?
Okay. So we identified WIP a couple of different ways on the project. The easiest way is to actually walk around a construction site, and you tend to see a lot of it. However, through the processes, what you can see is within the system there, so within that model that I showed you, you would have ended up with a whole bunch of WIP pretty much sitting in storage, waiting on the stacking facility to move through it. We would have had a whole bunch of modules sitting on site, waiting to get through that system. So that's where the WIP was going to build up for us. We use various different tools within Chevron Production Manager. We use some dashboards. So when you have a standard work process, you can see where the bottleneck is and where the WIP is sitting. One thing I also want to mention is that it's not zero WIP. So it's not zero work in process. You have to have the right amount of work in process to ensure that the throughput is optimal as well, and you can get good cycle times as well. So it's a little bit like, sometimes people sort of say just in time, and we're not. No, it's not just in time. We need the right level of inventory or the right level of WIP in the system to ensure that the flow of work is continuous.
Excellent. Thank you so much, Craig. And one thing that I would like, this is not a question, but perhaps a comment, because you presented something along the lines of one of the outputs of your production system model being 140, I think was the number, capacity utilization on an element of the production system, right? And so what it might be important to re-emphasize is that the idea of a bottleneck is really an operation that has the highest capacity utilization, right? And so people typically refer, oh, the bottleneck is the slowest step in the process. Well, the question is, why is it the lowest step in the process? Is because typically is the one that has the highest, over 100 or close to 100 capacity utilization, right? And so as you said, operation science allow us to look at that. So I just wanted to highlight that element of your messages. So with that being said, once again, Craig, thank you so much for your openness, for coming here and sharing what you are doing, what you're thinking about, the opportunities, and how Chevron is making it happen. So always good to be inspired by people like you.
Excellent. Thanks everyone for
Thank
attending
you.
the symposium.